Hello, in this video, we're going to be introducing logarithms. Since there is a lot of content to cover for this concept, this video will be the first part of my logarithm video series. I'm going to advise you not to move on to the next video in this series until you fully understand the content in the previous video. With this being stated, I'm now going to move on to the content of this video. First, let's start off with defining what a logarithm is. A logarithm is defined as a quantity representing the power to which a fixed number, the base, must be raised to produce a given number. Now that we have defined a logarithm, let's take a look at what a logarithm looks like. As you may be able to see, logarithmic functions are the inverse of exponential functions. While exponential functions tell us how many times to multiply a base number by itself to express a particular number, logarithmic functions tell us how many times a base number must be multiplied by itself to get some particular number. Before we move on, let's examine the parts of a logarithm. The b is the base of the function. The x is the argument of the function. And the y is the exponent. Now that we have examined the parts of a logarithmic function, let's examine some of its basic properties. The first property is the log-based 1 rule. This rule says that the logarithm of 1 to any base is always equal to 0. Next, we have the identity rule. This rule says the logarithm of a base that is equal to its argument is always 1. Then we have the product rule. This rule tells us that the logarithm of the product is the sum of the logarithms of the factors. Next is the quotient rule. This rule tells us that the logarithm of the ratio of two quantities is equal to the logarithm of the numerator minus the logarithm of the denominator. Finally, we have the power rule. This states that the logarithm of an exponential number is equal to the exponent times the logarithm of the base. Before we move on to our practice problems, I will do an example that demonstrates how logarithmic functions are useful. Here we have a log base 3 of 27. We could write this as 3 raised to the power of x is equal to 27. So we want to figure out what that value that x should be equal to make this statement true. Let's see if there is a way we can evaluate this logarithm to find out what x is equal to. We want to find out how many times you have to multiply 3 by itself for it to equal 27. Think about the power rule. We can use this rule to multiply the exponent of the argument with the logarithm. We know that 3 cubed is equal to 27, so let's write it this way inside of the logarithm. Now we know that the logarithm of a base that is equal to its argument is always 1. So this means that the logarithm base 3 of 3 is equal to 1. And this is what our x value is equal to. X is equal to 3. I hope this helped your understanding of what a logarithm is and why logarithms are useful. Now let's try some practice problems. Right away, I see two logarithms of the same base being added together. This tells me that we can use the product rule. Additionally, I see a logarithm where its base is equal to its argument. This tells us that we can use the identity rule. The first thing that I am going to do in simplifying this expression is cross out the log base 4 of 4 because it is equal to 1. Next, I'm going to combine our two logarithms together. where their arguments are being multiplied. We can do this by the product rule. So we have log base 2 of 8 times 7 times 1. 8 times 7 is 56. So we have log base 2 of 56 times 1. And this is going to leave us with our answer, log base 2 of 56. Let's do another example. This time, try pausing the video and see if you can figure it out on your own. So I am immediately able to recognize that we have logarithms of the same base being subtracted. This means that we can use the quotient rule. This is going to give us log base 3 of 162 divided by 2. This is equal to log base 3 of 81. Let's see if there is a way that we can simplify this logarithm to a number. So let's think back to the power rule. Let's also think back to the identity rule. Let's see if 81 is divisible by 3. I know that 27 times 3 is equal to 81. This must mean that there is some power that I can raise 3 to for it to equal 81. In this case, this power is 4. Using this rule, we will bring the exponent to the front of the logarithm, or it will be multiplied by it. Additionally, our logarithm will be equal to 1. This is because its base is equal to its argument. This will leave us with 4 times 1, which is simply 4. And that will be our final answer. That's all for this video. I hope it served as a nice introduction to logarithmic functions. Take care.